Hello, my name is Andrew Griner, and this is Lab 3, the Black Hole Orbit. The objective for this lab is to calculate the forces acting upon a star by analyzing its motion data. As a result of this lab, we successfully calculated the forces acting upon the star, as well as calculating the mass of the black hole. Now let's start the lab. The main physics principle used in this lab is Newton's second law. Newton's second law is used in situations where F net is not equal to 0. We know that F net is not equal to 0 for our star because the direction of the star's velocity is changing. The first form of Newton's second law will be used is F net is equal to the change in momentum over the change in time. The second one updates the velocity of the star in our computational model. We will also use the component form of F net, which splits up F net into F net parallel and F net perpendicular. F net parallel represents a force acting in the direction of the motion of the object, and the perpendicular reflects the force acting on the object perpendicular to its motion. The only force that comes into play in F net is a gravitational force and is equal to the equation shown here. Our objective is to find the net forces acting upon the star, given only the star's motion data. Now, to do this is quite simple, but requires a few steps. We know that F net is equivalent to delta P over delta T, and we know that delta P over delta T is equal to the mass of the object times delta V over delta T. Since mass and delta T are given, all we are concerned about finding from the motion data is delta V. In order to find delta V, you need 3 position points. With the first 2 position points, you find the initial velocity by subtracting the 2 position points and placing that over delta T. To find the final velocity, you do the exact same thing with the second and third points. Now that we have a final and initial velocity, you subtract those from each other and find delta V. With that, we can find F net at a certain point. Now with this knowledge, we will construct our computational model. These are the important bits of code used in our computational model. Our 2 given values, the mass of the star and delta T, are placed in the system properties and data here. These 2 loops are necessary to do the data analysis that I explained to you in the previous slide. The smaller loop calculates the velocity of the star at a given point by subtracting 2 adjacent position values. This larger loop finds F net parallel, and F net perpendicular. To find F net, we need to find dp/dt. Finding dp/dt is done by the method that I explained to you in the previous slide, which is multiplying the mass of the object by the change in velocity and placing that over the change in time. Doing this gives us F net. In order to find the parallel and perpendicular component of F net, we need to find their equivalent values, which are the parallel and perpendicular component of dp/dt. To find the parallel component of dp/dt, we need to find the change in the magnitude of the momentum and place that over delta T. Then we multiply that by the direction of the motion. This reflects an increase or decrease in speed of the star. Now to find the perpendicular component of dp/dt, we simply subtract the parallel component by the total dp/dt value. And this gives us F net perpendicular. Here's how the computational model runs. From it, we can view the motion of the star, see visual representations of the forces being applied to it from the arrows, and obtain the F net parallel, and F net perpendicular values, which are printed here. Calculating the mass of the black hole is quite simple. Since we know the force of gravity from the computational model, and the force of gravity is the only force that plays into F net, and we are given distance, all we have to do is solve for the mass of the black hole in the gravitational force equation. And from that, we obtain 3.18239 times 10 to the 31st kilograms. Our what does it mean question is to describe the difference between F net and its components and dp/dt and its components. dp/dt is a property of an object. F net is something from the surroundings of an object acting upon an object, causing its dp/dt value to change. Putting it in more simple terms, F net is the cause and dp/dt is the effect. Also, the components of F net cause the components of dp/dt to change respectively. Our what if scenario is to imagine that the black hole was removed and replaced by a new black hole in the same location. We are also assuming that the motion of the star remains unchanged and is only affected by the gravitational force of the new black hole. Now, can we tell the difference between the black holes, or in other words, can we determine the mass of the new black hole? Since the motion of the star remains unchanged completely, we can assume that the net forces acting upon the star are the same as well. Since the net forces are equal to the gravitational force being done on the star by the black hole, and the mass of the star and the distance between the two objects remains unchanged, we can assume, by use of the gravitational force equation, that the mass of the black hole remains unchanged as well. So, yes, you can find the new mass of the black hole.